Tenakwe, ko Albert Rifetto ko Inoa. Welcome to this introduction to AI course. This is a course that we are doing for the AI Hackathon organized by AI Forum. So this is a course of 2 hours from 2 to 4. This is a basic course on fundamentals of AI. So there is no programming required. This is the first of 2 courses. We are going to do another course tomorrow from 9 a.m. to 3 p.m. This is going to be environmental AI using Python. And this is a course that is going to be more advanced and is going to be for people using Python and notebooks to program. And that is going to be very useful for the AI hackathon that's going to be run later this week. So, yeah, my name is Albert Rifet. I'm director of the AI Institute here at the University of Waikato, and I'm also the co-chair of the New Zealand AI Researchers Association. And I'm going to be giving this online course with Anani Duvedi. He's a researcher here at also the AI Institute here at University of Waikato. So both of us, Anani and myself, we work at this Tayao project. So this is a big environmental data science project of 7 years. This is with University of Waikato, Auckland, Canterbury, Wellington, and Becca, and Met Service. And basically what we do is we try to help environmental scientists to benefit from AI and data science. So we have this nice community website that you can find at tayao.ai, where you will be able to find data sets, notebooks, and a specific software that you can use for doing AI and data science.
Just a second. Yeah, some people are not hearing, some people are hearing. That's weird.
Sorry, it seems that is an issue with the sound. Let's check. Can you hear me? Can everybody hear me?
Yep, I'm all good, Albert.
Thank you.
This means.
Yeah.
Yes, I can hear.
Yeah. Okay.
Okay, so it seems that it's working. So I'll continue then. Thank you. So the agenda for today is we're going to start with a very basic introduction. Then we'll talk about what is AI. We'll discuss a little bit about what is open source AI, and we'll finish with the risk and ethics of AI. So this is going to be the first part. Then we'll stop. We'll do a short break. And then after the break, we'd like to do a practical session using building an AI system. It's going to be classifier using this Google Teachable Machine. So I think it's going to be fun, and you don't need to program. You'll see it's basically something that you can do using your browser and the camera of your laptop or desktop. Cool. So let's start. So as you know, AI is really, really hot topic right now. So this is something that has been there for many years. In 2018, the Google CEO, he was already saying that AI was going to be more important than fire or electricity. It's quite interesting because, yeah, it's more, I think it's really going to be like the internet. It's going to change everything, but maybe this time is going to be much faster. As you know, there is a lot of advancements. It's very exciting to be looking at AI right now because every week there are new things. So, for example, from OpenAI, we had this last model, GPT-4o, that was really much better than the previous GPT-3 and GPT-4. But also Google is working quite hard on that. And they have these models called Gemini that they are also trying to compete with the GPT-1. But if you see, there is right now so many competitors. There are so many large language models. So it's quite exciting to see every week what is appearing. Also Apple, if you look at that now, they are also they realize that AI is really, really intelligent. They call it Apple intelligence, but basically what they want is really to improve how they people can use their iPhones and their laptops and their desktops. So one way is to upgrade Siri, and this is something is coming. So we'll be able to have a Siri that will be linked to ChatGPT, and that's going to be more advanced. There is also this idea of trying to run the models on the devices and not on the cloud. So this is also something quite exciting that is coming. So in terms of AI, you can realize that this is something quite big right now. If you look at the largest companies in terms of market capitalization, you will see that right now they are Microsoft, Apple, Nvidia, Amazon, Google, Meta, Facebook. So all the big tech companies are the ones that are benefiting from AI because they are big enough to have a lot of data and a lot of computing power, are the ones that are the biggest ones in market capitalization. So when we talk about AI, I think it's very important that we think on a data-driven intelligence, right? Because there's many ways that we can see AI, but it's really important that we realize that right now what we have is something that is based on the data. So we'll see that data is the core, and without this data, we don't have this idea of talking, instead of artificial intelligence, we should be talking or augmented intelligence or data-driven intelligence. So in terms of what are the benefits of using AI, so this is a report from Deloitte, and they realize that asking companies, they think that maybe two main things. One is how we can improve productivity. So this is one big thing. And the second one is how we can improve the products and services. It could be or reducing cost or innovating. So I think this is maybe the main two things that people are excited about AI, just improve efficiency and productivity, and at the same time creating new products and services that are more innovative. So it's quite interesting that the companies that are really, really benefiting from AI, they are not only traditional companies that they use AI systems or AI models. There are companies that they have data in the core. So why? Because they decided that they are technological companies that they use data as the core. So why that? Because with more data they get a better product. With a better product they get more users. With more users they get more data, and that's a cycle, right? This is a virtuous cycle. So they are really interested on having data because that allows to have better products and get more users. So that's the difference, right? So the companies that are really, really AI based, they get data on the core, and they are, let's say, more technological companies using the technological companies that they are doing specific operations, but not they are really, really AI based. Okay, and as you may know, AI is really now a hot topic since November 22 when ChatGPT appeared. So as you may know, ChatGPT is a large language model-based chatbot. It's developed by OpenAI, and the nice thing of ChatGPT is allows writing prompts to have some very, very nice outputs. So one way to see these large language models or ChatGPT is really like a modern computer where instead of programming in Java or Python, we program in English. So the idea then is that instead of writing a program in one of these computer languages, we're going to use a prompt. It could be quite long, could be a prompt that could be 3-4 pages of text specifying all the details. And this is going to be the program. And then these large language models is going to be really, really like the computer. So what are the best way to use ChatGPT? Well, the most important thing is that we really need to provide clear and specific instructions. So this is really, really important. And the other principle is that we need to do it slowly. So we need to divide the task into subtasks so that we give the model time to think. So it's really, really important to do that in a slow way so that we minimize the errors that this ChatGPT can do. And the way to do that is we need to do that in an iterative way. We are not going to do it right with the first prompt. So we are going to write the first prompt, see the output, identify the areas for improvement, and then refine the prompt and repeat that until we are happy. So it's really, really an iterative process. So we need to do that many, many times until we are happy with the result. So in terms of errors, unfortunately, these systems are not 100% correct. They do some mistakes. So maybe there are 3 types of mistakes. So the first one is algorithmic errors. So this is something internal. So for example, if we ask GPT-4 to repeat the string space DVGL, it's going to cannot do that, and it's going to repeat the string GNDL, and that's due to an internal algorithmic error that is causing this error. Another type of error is these reasoning errors. For example, if we ask, write the title about a book on Tauranga without using the letter A, so yeah, it answers, gives a title, but you see it's Sunlight Shores, Tourist Culture and Life in New Zealand's Harbour City, but it contains the letter A. And when we told it that it contains the letter A, yeah, it says, yes, you're right. And then it tries again, but again, it's doing the same mistake. So reasoning is one of the types of errors. And finally, the last type of error is hallucination. So is creating text that may be fiction. So for example, we ask this book on machine learning for data streams. So the first books are correct, no problem at all. But the last one, Ensemble Methods for Stream Learning and Online Learning by Albert Buffet, Ricardo Gavalda, Jeff Holmes, and Bernard Faringa, this is false. This book does not exist. So these hallucinations that happen, right? So this is why these systems cannot be autonomous. There is need always to check, because maybe 80%, 90% will be correct, but there is always this 10%, 20% that is not correct and needs someone to rectify and to change it. Cool. So that was an introduction. So now, what is AI? So there are many ways to see AI. I really like this definition from the European Commission that says that AI is a collection of data, algorithms, and computing power. It's very simple, but I like it because it allows us to understand what is AI and what is not AI, right? So it's basically data, algorithms, and computing power, and no more than that. So it means that that explains also the success of AI, right? So why we are talking about AI right now and not 10 years ago? So because now we have more data and more computing power. So this is why this definition is quite good, because we can understand what is AI and what is not AI. So let's look at the 3 things. So let's look at data, algorithms, and computing power. So let's start with data. So yeah, the first thing is that the AI models right now are so powerful because we have a large amount of data that we can use to train the AI models. So if you look at this figure, this is a training data set size. We'll see that over the years, the size of the data set is increasing. This is a chart where the scale is logarithmic. So you can see that the growth is really, really exponential. So this may be one of the reasons why AI the models are so good. So what these large language models are using, as you know, ChatGPT is a closed system, so we don't know, but we can know what the open source models are using. So this is from the first paper of Facebook Meta about Llama, these open source models. And what we realized there is that most of the data is from the internet. So we see, if we look at the data set used are Common Crawl and C4, basically from the internet, GitHub, Wikipedia, books, archive, Stack Exchange. But if we look Common Crawl and C4, it's already 4 terabytes of data. So it's really, really, really important. And we have GitHub and Wikipedia. So GitHub is this website for open source programs. And that's why these models are really good at programming, because they have a lot of data on open source programs. So you see, this is the data that is used. So as you see, all the answers from large language models are going to be based on this data. So if it's on the data, that's going to be able to answer, you'll be able to use it. But if it's not there, it's not going to be able to use that. We'll go into detail on how a large language model is built later on. And another important thing about data is that the quality of data. So it's really, really important that we use good data. And that's, we'll see that in many processes, we really need to clean the data to prepare that, because if these models are going to be based on data, so if the data is wrong, the output is also going to be wrong. So it's very important to check that all the data is correct. So it means that there are no missing values, that there are no incorrect entries. So maybe there are duplicates, there are inconsistent, maybe they don't make sense from the domain knowledge perspective. And another way that we do to improve the data is to scale and normalize. But it's really, really important to look at which data we use to train these models, because the quality of the output is going to be reflected depending on the quality of the input data. Okay, so that was the data. So now let's move to the algorithms. So AI is really, really a big field. So there are many, many types of algorithms, many types of methodologies, many types of subfields, but the ones that are used for these ChatGPT and these large language models are based on machine learning. Deep learning is the specific subfield of machine learning that uses neural networks, and generative AI is this new subfield that is the one that is able to generate text, images, audio. And finally, we have large language models that are a subfield of generative AI, and GPT is one of these models. So in terms of machine learning, just to show what are the different types of algorithms or methodologies. So when we look at tabular data, so data that is in a spreadsheet in Excel, so it basically is a table. In a table, we have columns and we have rows. So if we are trying to predict the values in columns, this is going to be classification or regression, depending if we are looking for a number or for a label. If we are looking for a number, it's regression. But if we are looking for a label like positive, negative, name of a city, name of a color, then that's going to be classification. And in terms of the rows, if we try to group them, then this is clustering. And if we try to find what's the rows that are different, that are not normal, this is going to be anomaly detection. So these are the different types of machine learning algorithms. So we say that the ones that are looking at the columns are supervised methods, because we need to learn on these type of labels. And the ones on clustering and anomaly detection, this is called unsupervised, because we don't need the labels for that. So let me give you an example. So imagine that we have a website and we want to classify visitors. Means we have a visitor and we want to predict if this visitor is going to be a customer or not. Okay, so how we do that? So the traditional way is that we have someone that is have a lot of experience and then has his own mental model of if a visitor is going to be a customer or not. And so when we have data, we have, let's say, all this knowledge is going to be in a spreadsheet or in a table, in a database, and we have all of this information. So this information is what we call the data points, right? So we can see this in this example, we can say the data points are these points inside the map of New Zealand. We see the red ones are the customers and the blue are the non-customers. So now what we need to do is with this data, we need to create these machine learning models. So I'm going to show you some examples. So, we want to create this machine learning model so we can predict when new visitors arrive, if they are customers or not, based on the previous experience that is on the data. Okay, so the most simple one is the majority class. So the majority class classifier is very simple. We count how many points are from one class and how many are from the others, and we choose the one that is the majority. So in this case, there are more non-customers than customers, so we are going to predict non-customers. So this is really, really simple. And as you can see, this is not the best one, but this could be the base one. So at least we need to do as good as this one. Because if we are not doing it as good as this one, then our model is really not good. So another one is this linear classifier. So that's really simple. You see, line, the data points on top are customers, the ones below are non-customers. Another one is the nearest neighbors. So this one, we're going to look at the most similar data points in the neighborhood. So for example, imagine that we look at 2 nearest neighbors. We are going to look at these 2 nearest neighbors, and we are going to look at what is the majority class, and we are going to predict that. So usually in this case, the distance function is really similarity function, right? The points that are close are the points that are more similar. So that's also a very popular classifier. Another one is a decision tree. So a decision tree is quite good for 2 reasons. One is because it's explainable, so we can understand how the predictions are made. And when we use them in ensembles, like 100 ensemble of 100 trees, the methods are very, very powerful. So this is an example, for example, of a decision tree, right? So the root node is island if it's north or south. If it's south, it's non-customer. If it's north, it depends on the region. It's going to be customer or non-customer. So as you see, every time we do a prediction, we can understand why this prediction is made. And this is something is going to be very good in terms of explainable AI. So every time we do a prediction, we want to have an explanation. Ensemble. So a way to improve the performance of one classifier is to, instead of using one, is to have a set of models. So instead of using one decision tree, we are going to use 100 decision trees. And then we combine them. So a very popular method is called random forest. So what it's doing is combining these trees, and to make it more powerful, the trees needs to be diverse, needs to be different. And the way to do that is using randomization. So instead of using all the attributes to create the tree, we are going to use only a random number. So these methods, these trees are not going to be very good, but combining them, we are going to have a very, very strong classifier, a very strong method. So this is why these ensemble methods are really, really good. And finally, deep learning. So this is another method that is based on neural networks. So the idea is that we are going to build these classifiers using a network of artificial neurons. Now, let me explain a little bit this. So neural networks are really, really good for non-simple data. So for complex data like images, audio, video. So the idea is that when, for example, in this case, imagine that we want to build a classifier for images, and we want to classify if the animals, if there's a penguin, elephant, or kangaroo. So the images are really, really only a set of numbers, set of pixels. And then we have a set of pixels, and each pixel is going to be a number. We may have a different number for each one of the 3 colors, but it's only that, it's only a set of numbers. So how we get what are the features? So the nice thing of deep learning is that it's going to build using the data, doing many iterations. It's going to build these intermediate features. So we'll see here, for example, we have this elephant, right? And deep learning in these different layers, the neural network is the combination of different layers of artificial neurons. We are going to build these intermediate features that are going to be useful to decide which animal we want to classify. It's really interesting. So this is something that before in computer vision was done manually, trying to find what were the intermediate features. Now deep learning is helping to do that. Of course, using a lot of data and a lot of computing power. So this is what is needed to be able to do that. But it's very nice because in an automatic way, it's able to find these intermediate features. And finally, in terms when we have, we don't know if these data points were customers or not, still we can get useful information. We can get, instead of what we call classes, we can get groups. We can group the data points by groups. And there are many methods, but maybe the most popular ones are k-means, when we are looking at the points that are nearby in terms of distance. And DVScan, this is when we get the groups by the points that are density connected. Okay, so the ones that they are not nearby, but they are really, really connected. So from one point, we can go to the other point. So maybe this is our two main methods for clustering. So with that, now that we can understand a little bit how these algorithms work. So for example, if we have a self-driving car, what a self-driving car can do really well? Well, everything that was on the data, right? So it can detect cars, everything that was on the data that were, let's say, millions of points, it will be really, really good. What the self-driving car cannot do is when something unexpected happens, when something that was not on the data, so someone making a sign, doing something that was not on the data, then there is no way that the self-driving car can understand what needs to be done. So that's why we like this idea of data-driven intelligence, right? So everything is still based on the data. Good. So that was a little introduction to machine learning. So now let's see how ChatGPT works. So there are like 4 different stages. So maybe the most important one is the first one. It's called pre-training. The idea here is that we're going to get all this data from the internet. Remember, it's a huge amount of data, so it's really big data. And we are going to build a model that is going to predict the next word, the next token. And this is going to be something that we are going to be using neural networks based on transformers. This is going to be very expensive. We're going to use thousands of GPUs. We're going to have to do it in months of training, and it's going to be very expensive, like $100 million. So it's really the big thing, right? So a lot of data, basically from the internet, the ones that we saw before. From there, we are going to predict, we're going to build a model that is going to predict the next token, and we are going to spend a lot in computing power. So yeah, the basic idea is that we have a text, and this algorithm is going to predict the next word. For example, here we have the cat is. So we have these tokens. So internally, this is going to be in numbers. For example, in this case, the cat is 464, 3,797, 318. And the model is going to predict the next word, black. So internally, this is going to be the token 2042. So you see, it's very, very easy. And this is what these large language models are doing. So we start the text, and then they are continuing generating the next words. So this is why we call it generative AI, because they are generating the next tokens. But it's very, very simple. It's only generating the next word, and iterating this, they are capable of writing long outputs. So that was the first step, right? You see, big amounts of data, very expensive computing power, and we have these models that are able to predict the next words. Now, how we can improve that? Well, we already used large quantities of data, right? So now what we can do is that we can improve that using quality data. Instead of quantity, quality. So this is why now we are going to use data that we are going to pay contractors to write specific answers, the ones that we want the model to output. So we are going to ask contractors, this is called supervised fine-tuning. We are going to ask them, okay, let's write as high quality outputs so we can use this to improve the model. So this supervised fine-tuning is really not so expensive because the amount of data is not too big. So instead of using thousands, we can use be less than 100 GPUs, and we can do that only using days of training, and could be really, really much cheaper than the first one, the pre-training. And this is something that you see people are doing right now, right? We can, building the big large language models can only be done by big companies or big organizations. They can spend millions of dollars doing that. But what we can do is use, for example, these open source models, then this supervised fine tuning. So this is the second step, okay? Now, the final step is we can use the human feedback. So if you ask a contractor to write a poem, maybe that's going to be hard, right? Because not everyone is a poet. But we can ask them to compare and select what is the best poem between 2 or 3 options. So yeah, let me show you an example. So imagine that we have a prompt is described around in a sentence. We have 3 different outputs of the large language model. So what we are going to ask the contractor is to rank them, to see what is the best one. For example, in this case, the last one is the one that maybe the best one. So the contractor is going to rank first one, the last one, and the second one is going to be the first one, and the third one in the middle. So as you can see, this is something that also is quite useful because can help to improve the model. So you see that these models are really, really interested in getting as much data as possible. And this one is also a data of high quality. So yeah, that's the pipeline. So there is this big first stage of pre-training. This is the one that we need thousands of GPUs, large amounts of data, basically from the internet. And with that, we have this model that is going to predict the next token. Then with that, we are going to improve that with high quality data. So usually these companies, they pay contractors to write high quality outcomes. And from that, then we are going to use the human feedback to improve how these outputs can be done. And you will see if you use ChatGPT or these models that they are always asking for your feedback. They're always trying to ask you if you like it, not, because then they can use this information to improve the models. Great. So that was how ChatGPT works. We are going to move now to computing power. Remember, we're saying AI is data, algorithms, computing power. So we are going to look at this computing power aspect. So yeah, we mentioned before that now we have large amounts of data what we didn't have before. So also it's interesting that in terms of computation, we have now a huge amount of computation that we didn't have before, right? So if we look at the amount of computation that we are using to train AI systems, we see that before 2010, we were doubling every 20 months. And now we are doubling every 6 months. This is, again, you'll see that this is a logarithmic scale. So it means that we are really, really increasing exponentially. And that's really important because this is the main reason why we have these very powerful AI models, because we have these large amounts of data and these large amounts of computing power. Of course, there is a trade-off, is that we're going to be using a lot of energy. So, for example, if we look at the passenger traveling from New York to San Francisco, this is going to be 1 ton of CO2. If we look at the lifetime of a car, this is going to be 63 tons of CO2. If we look at GPT-3, this is going to be 500 tons of CO2. If you look at GPT-4, that should be at least 10 times that. And if we look at GPT-4o, that could be also 10 times the ones needed for GPT-4. So it's really, really, we are using a lot of energy to build these models, and then also to when we are using them, right? So for example, every time we do a query on We do a prompt on ChatGPT that maybe 10 times the energy that we do when we use a Google query. So we are also starting to use much more energy when we are using these models, not only when we are building them, but also when we are producing them. Okay, so that was the AI part. What is AI? So now we'll move to the open source. I think it's quite important to talk right now about open source. This is something that is not new. We have been discussing about open source since the 90s, when we started this discussion between Linux and Windows. So Microsoft at the beginning were really not open source friendly, but now they are, they moved to be really open source friendly. They bought GitHub, so it seems that changed. So it's quite good that for many years, people were happy to know that the two ecosystems should coexist: the closed ones and the open source ones. It's good that in large language models now, at the beginning was not clear. There was some discussion about that these large language models were so powerful that maybe they should be closed and only a government should decide who can work on this. But finally, this is clear right now that we really need to have both closed and open. The advantage of the open ones is that we can understand how they work. With the closed ones, it's private. It belongs to the company, so we really don't know how they work, which data they use, which models they use. So the nice thing of open source is that we can understand how they work. And in this case, Meta and Facebook were really supporting open source models, and they have been releasing these Llama models. For example, the last one is this Llama tree, and this is a really powerful method, but they are open source. So it means that we can really use them in our own desktop or in our own mobile in the future. So this is how these things are moving. So, for example, Google also is providing open source models. Remember that the closed ones are called Gemini, and the new ones that are open are called Gemma. So again, now it's nice because we have the two ecosystems. We have the ones that are closed, like ChatGPT, Claude, but we have also the open ones, like this Llama, Gemma, Mistral, and many others. So it's quite exciting to see how these models are competing, but also how we can understand how these models work, because we have some open models. So it's very interesting that I think this is something not many people know, is that New Zealand has been a pioneer on open source models, on open source AI. There are two projects that was started at University of Auckland, and Weka that started at University of Waikato, that has been very popular around the world, and many people are using them in universities to teach machine learning, AI, statistics, but also in companies, because they are open source projects, so the people can use them freely. So it's something that is a huge impact of New Zealand in the world in terms of AI, and that's really something that we can be very proud. So as we are from the University of Waikato, let me mention this Weka software. This is the open source software in Java. Has been very popular. There is this book, Data Mining. So there are also some more courses, more than 10 million downloads, and more than 18,000 research publications. So let me show you. This is a video. We will see only the starting point. This is from Google for developers, and they are talking about Weka and how to use Weka for doing AI and machine learning. So it's nice to see people from Google talking about open source software from New Zealand.
Hey everyone, today I'd like to make a quick video that I hope will be concrete and useful for you. It's about the very first machine learning library I ever tried, and it's called Weka. What's great is that Weka comes with a GUI that makes it easy to visualize your datasets and train and compare different classifiers. And this is a really handy tool to have while you're learning ML. I'll give you a quick walkthrough of how to use Weka, from installation all the way to running experiments, and show you some of what it can do. I'll demo training models on 2 different datasets. First, we'll predict if a patient has diabetes based on attributes like their glucose levels. And next, we'll predict if a congressperson is a Democrat or Republican based on how they voted on different bills. I'll also show you how to evaluate the results of these experiments and how to do things like feature selection to discover which attributes are important. Okay, let's dive right in. The first thing we'll do.
Okay, so you can watch the video if you are interested, but yeah, it's quite nice to see, in this case, Google for developers explaining how to use Weka. And it's very, as you can see, it's very simple. You can use it from a graphical user interface. There's no need to program, and it's very, very powerful in terms of what can be done. Great. And yeah, just to finish this part of the course, I'd like to talk about risk and ethics of AI. As you know, there's a lot of advantages of using AI, but again, we need to look also at the risk and the ethics. So maybe the main risk is how we are using AI right now. And it's not about having responsible AI, it's about having responsible people using AI. So at the moment, AI is really a tool that helps people to speed up things. So it's very important that we talk about responsible people using AI. So it's not about the technology, it's about how we use it. So technology can be used in good ways or in bad ways. So in terms of when we look at AI ethics, I think it's like when we're looking at AI, right? AI is data, algorithms, and computing power. So when we talk about ethics, we should look at the same. So in terms of data, we need to look at fairness, bias, at privacy and sovereignty. And in terms of algorithms, we should look at explainability. We're going to look at this now in more detail. But so the first one is, let's say about privacy. We need to be sure that the data that we are using, we have the agreement and the consent to use it. And this is something specific important for Maori data sovereignty. It's really important that we consult and that we have the agreement that we can use that data. So this is a very important step when we talk about ethics. The second one is about fairness, about biases, about not discriminating. There are these famous cases of big mistakes. So there was one of Google that was built a classifier with images, and then they trained the model not with only using pictures of white people. So they were really very bad at classifying Black people. So that was really a big issue. And this is why these biases are really important to check. Another interesting case was Amazon that was using AI system to help recruiting people. And yeah, since it seems that Amazon was recruiting more men than women, the tool learned that they had to recruit men. So there was clearly a big bias there, and there was clear a big discrimination there. But the problem is not that the model was discriminating. The problem was that the data, the bias was on the data, and then the algorithm, the model was repeating the bias that was on the data. So this is why this is something that we really need to check, that we are not doing any mistake on that. And yeah, another important thing is about explainable AI, about the algorithms. So it's very important that every time that we have a prediction, that we have an explanation. So this is something that also is crucial, because it's a way to check that there is nothing wrong, that what we are doing makes sense. So as we mentioned before, when we are talking about decision trees, so a nice thing of decision trees is that are models that we can understand how the prediction is made, right? In the terms of the decision tree, we'll see what are the attributes that are used, and then why a prediction is made like this. So that's really good because in this case, we don't need to do anything. We use a decision tree, and we already have the explanation. But sometimes we need to use more powerful methods. And then when, for example, deep learning, we can use these big neural networks. And then these methods are not explainable. So what we need is to find an explanation. We are lucky that we have several methods that we can use to get this explanation. So for example, Lime and SHA. So in this case, we can use these two methods. And then at the end, we can get some specific values for each one of the attributes, so we can understand how the prediction was made. So for example, in this case, Lime is based on building local models that are explainable so that we can use these local models to get an explanation. So this is a very simple but also very powerful method. So at the end, we can understand when a prediction is made, so when a prediction is made, what was the explanation, right? So here, for example, yeah, we have an example. We want to make a prediction. So we have the attributes, and then we want to predict bad or good. So yeah, looking at this, we can understand how the predictions were made. And with the SHAP values, it's something similar. We can understand what are the importance of the different features, so we can understand the prediction. We have an explanation, and this is really, really important. So it's not only for tabular data, so we have this also for images. So this is something that also is very important. When we have images, we are really interested on the pixels that we are using to make the prediction, right? So for example, here, we are classifying an animal, if it's a cat, a dog, it's really, we need to know why the system is making this classification, right? And for example, what are the pixels that in the first image is selecting that is a dog, or in the second image, what are the pixels that are used to predict that this is a cat? So this is really, really important. So why is so important? Well, because if not, we may be doing mistakes. So this is a very famous example. We have this image, we have this classifier, and then this, in this case, when the classifier was predicting nicely, but when we look at the pixels that were used to make the prediction, we see that the prediction was made basically using the background, not the animals, because we had in the training data set, we were using images from this specific animal that were always with that background. So the machine learning algorithm learned to use the background instead of using the pixels from the animal, right? So yeah, it's quite important that every time we have a prediction, that we have an explanation. Great, and finally, so remember we mentioned we have AI as combination of data, algorithms, and computing power. Of course, this is something that we need to start thinking about how much energy we are using, right? And this is something that is at this moment, maybe it's not important, but this is something that we may need to face in the near future, because as you can imagine, we are building more and more data centers, more and more computing centers that are using cloud technology, and that the percentage of energy that we are dedicating to AI is growing. Still is quite small, but if we are going to be using AI in a ubiquitous way, in a ubiquitous manner, maybe then we need to really start thinking how we can reduce the amount of energy that we are using. And for that, yeah, we can say that this sustainable AI or green AI is something important to start thinking about, right? So we don't need only to look at the performance of these models, the accuracy of these models. We need also to look at the carbon print how much energy we are using for these models. Okay. So yeah, so I think that we are finishing this first part of this course. So we gave an introduction. We talk about what is AI, so about this idea of data, algorithms, computing power. We talk about ChatGPT, how ChatGPT works. That is based on this idea of first pre-training, large amounts of data, then self-tuning with high quality data, and then human reinforcement. And finally, yeah, we talk about open source, the importance of open source software, and the risk and ethics of AI. So that's the first part of the course. We'll do now, we have time for some questions. And then after that, we'll do a break. And then when we come back, Anani is going to be giving this practical session on how to build an AI system using Google Teachable machine. So yeah, now time for questions.
So Nick already addressed a few questions, but there's some that we left for you. So one of them is, does sovereignty apply to data from non-Maori?
Yeah, that's a very good point. Yeah, so sovereignty applies to all data. It's clear that Maori are focusing mainly on Maori data sovereignty, but data sovereignty is a big thing that can be applied to any community or any organization that has data. So I think that it's like I think it's not the same, but it's quite related to privacy. So when we are talking about privacy, we are many times thinking also about data sovereignty, and yeah, this is really a general topic.
Then there's this one, this is quite long, so just
Thank you.
from my understanding.
Okay, yeah, so that's tell us more about the trade-off between generative AI development and use and its potential environmental costs and constraints. For example, the handbrake on the rapid AI won't be regulatory or ethical, but environmental. It's dependent on the vast quantity of resources, water and electricity needed to run mega data centers. Deborah Harding, Managing Director of the Market Research Society, Chair of the Vice President of the European Research Foundation, and expert. Yeah, ChatGPT gobs up 500 millimeters of water. Every time you ask it, it's a series of between 5 to 50 prompts or questions. Yes, that's, I think it's going to be the a very interesting discussion, because we are right now we are only looking at the benefits of using generative AI, and I think it's really easy to use. We have this free version, right? And then we are really not thinking on the cost of that. I think that in the future we are going to have, in terms of AI, we may have two big problems. One is in terms of availability of data. So maybe right now these models use all data that is available, and this is something people starts to think that maybe data should be more private, and so maybe it's going to get much harder to get this data. And then there is about the computing power, right? So this computing power is going to have a big impact in sustainability, in environment, and there starts to be a lot of research on that, and that's very interesting. There is some guidelines on green AI. So what countries and organizations should be start thinking on green AI. So that means that organizations will need to be certified on that they are doing the right thing, but also countries, they should have guidelines on how they show or guide companies and organizations to have a fair usage of AI in terms of using AI, right? So right now we can, for example, if we want to do a sum, we want to sum 6 plus 8, we can do that in a very cost-efficient way, or we can do that using a Google query, or we can do that using a putting that in ChatGPT, right? So it's the same output, but the difference in energy is going to be really, really big. So this is going to be part of the discussion, right? So I think that the fundamentals, ethics. So we are going to be talking about ethics. Once we want to continue, we should be talking about green AI. So how we not only do the right thing, but also we do that in the right way, so that we are really, really thinking on how to use less resources.
One that just popped up while we were replying to that. Oh yeah. Can you explain more about Lime and Shep?
Yeah. So maybe I can go back. So the idea is that we have these what we call black boxes. Okay, so black boxes are models that we don't know how they work inside. For example, a deep learning model is going to be a set of parameters, a set of weights. And from that, we can really not understand how this works or why a prediction was made. So then we have this idea of having this explainable algorithms. So Lime and Shep maybe are popular because maybe we're the first ones, but there is a lot of them right now. So how they work? So the idea is Lime, it's very, very simple. So it's going to say, okay, we cannot understand the outcome of a neural network, but we can understand the outcome of a logistic regression, linear classifier of a decision tree. So what we are going to do is that we're going to build a decision tree with the near neighbor points so that we have a small local model that we can get an explanation. And then it uses these explanations from there. And the Shep values is based on this idea that that comes from game theory, is what happens if we remove one of the attributes. So if we want to know what's the importance of each of the attributes, so what we are going to happen is what happens if we remove that feature. Yeah, we are going to check if that feature was important or not, right? So it's like the relevance of that feature. So this is how these Shep values work. So it's a main, it's a way to check the relevance of each feature, checking what happens if we remove them to see what is the consequences of doing that. Again, this is our very basic methods. It's there are nice ways. For example, if you use now these Python libraries, you'll see that it's very easy now to get, every time we have an prediction, to have an explanation based on these methods.
And the last one is, are the cybersecurity dangers of AI undersold by big companies looking to push these products, which really are in beta mode right now?
Yeah, so that's a good question. So the thing is, AI is going to be used for good things and bad things, right? And cybersecurity is a good example of that. So you can think that are going to be a lot of cyber attacks that are going to be using AI. At the same time, we're going to be using AI to defend from these cyber attacks, right? So the interesting thing is that this is like an adversarial setting. So it means that it's going to be, the attackers are going to be improving, the defenders are going to be improving. So it's going to be a continuous, let's say, competition on that. So of course, yeah, we are at the beginning. So there's a lot of research on that. There is a lot of investments on that. So I can imagine that these products are going to become better and better. But yeah, I think that unfortunately, this is like every technology, right? It's going to be used for good things and bad things. The nice thing is that there is a lot of people doing research on that. So yeah, it's going to be a lot of dangers on cybersecurity. But again, there is a lot of people working on how to defend from these attacks. So still, I think that yeah, it's going to be good in the long term. Thank you.
Data online, data that's online that's not hidden behind paywall, free for everybody to train their models on.
Yeah, so that's one of the big discussions about AI is about the data, right? So what data is being used and how that data was accessed, and that's the thing of the closed models that we really don't know. So for example, one interesting thing is that in terms of ChatGPT is really good at translating Maori to English, and this is something that still I think we don't understand why. And I think the explanation maybe is in the data that they are using for that. And this is something that as a closed model, we don't know. When we compare with the open model, in this case, the open models are not as good as ChatGPT translating to Maori. So that's also something that could be quite interesting to understand why ChatGPT is very good at that. Yeah. Good. Cool. Great. Thank you, everyone. So now we'll just do a short break of 5 minutes. So yeah, and then we'll continue after that with this practical session that Nani is going to give on building an AI system using Google Teachable Machine. Thank you.
Change the camera to use looking camera instead. Okay, how do you demonstrate sovereignty of the data?
Demonstrate sovereignty.
Okay. Okay, so yeah, hello everyone. Yeah, welcome back from the break. Yeah, so now I'll quickly discuss with you a bit about Teachable Machines, which is a web application that allows you to train your and test your own models, like machine learning models quickly. So currently they have three different applications that you can try out over here. One is with the images. For that, you can upload your own images from as a file from your computer, or you can use your webcam to get live images and then train based on that. Then you can also train a model that distinguishes between different types of sounds. So here they have an example of snapping and clapping. And then you can have also models that are decoding or tracking your pose and then decoding what type of pose you have. So yeah, they are still adding newer applications to it. So as I guess if you keep visiting here, maybe later on you'll find more applications that you can use this for. So how do you use it? So you just gather some data. You can define your own different types of classes. And once you've uploaded the data or used either the microphone for sounds or webcam for the images, uh, you can have different classes. You collect that and collect the data, and then you just press the button for training the model. And in background, it trains the model, and then you can test the model out in real time. So to show some examples, you can just click Get Started. And then here it gives you a choice of what type of project you want to do. So image, audio, and pose, like I already discussed. And then they are still developing more models that would be shared later on. So for this task today, we'll go with an image-based model. We'll just select a standard model. And then here you have two classes to begin with, and then you can add more classes as you want. You can also delete them, and then you can name your own classes. So for this example, let's say we want to do a model that uh, looks at the image from the webcam, and it's trying to find out if there is a hand in the image or not. So let's say we have one class as with hand and the other class as without hand. And then what you need to do is just select your webcam, give permissions. I have already given the permissions, so that's not an issue in my case. And then for recording the data, I just press the button here, and then I can start recording. So we should create some variability in the data set. Otherwise, if you just record the data with one pose and then you end up changing that pose, the model becomes really specific to that particular instance. And then in that case, it won't perform that well. So I just moved around a bit to have some sort of variances in the data set. And then I can go for the second class, which is without the hand. And again, move around a bit, collect some data. And yeah, roughly equal data set is always nicer. Once I've collected the data set, I can go and train the model. And here you can see it's training. And now the training's done, and then you can see the output. So with hand and without hand, and it was able to adapt for different hands as well. So that's how you can see that, yeah, we can we can. So,
Yeah.
and then as I move the hand away from the frame, it starts to get some confusion. Yeah. So, yeah, and then you have some sort of advanced features here as well. One is to change the number of epochs. Epochs is the a number of iterations it would do to do the training. So since this is a small data set, so 50 epochs is fine. If you have a large data set, you can play around with that, then play around with the batch sizes and the learning rate. And I guess, did Albert discuss? Okay, learning rate would be the step you would take to make the changes in the knowledge of the deep learning network. Yeah, and yeah, maybe if you want, you can play around a bit with this and discuss with us if you have any questions about the activity. You can either repeat the same task or you can try to train a model that does rock, paper, scissors and play with that. Yeah, so
Yes.
yeah, so you can use your own images, but you would have to upload them as file either from Google Drive or from your local machine. And you can upload the images and use those as the data set as well. We can see, yeah, it does detect fist as hand. Maybe the variable, there's some variability, but yeah.
You can give it a try, and then you can ever give it a try, and then if you have any questions.
Yeah, so you can give it a try, and yeah, if you have questions, we can discuss. And you can also export this model in TensorFlow format or JavaScript. JS is JavaScript, right? JavaScript format, and then you can also embed it into your Chrome browser, and yeah, just use it from there. Or you can import this and you can load it into your Python scripts as well. Yeah, tomorrow you'll learn more about PyTorch and a few other aspects of Python.
So this one is to
And
help
yeah, if you
create.
have any questions in general, feel free to ask them as well.
Okay, can I ask a question? Hello?
I can.
I can hear you, but maybe other.
No, yet.
I can turn on my volume.
Right. Remove the
Yeah, someone was asking a question.
Chat.
I think she was using the microphone to ask the question.
Oh,
Yeah.
sorry. Ask for permission to unmute. Yeah. Yeah. Can you ask to unmute, and I can grant the.
Yeah.
Yeah. I
Can you?
unmute them.
So whoever wants to ask question, can you ask to unmute and then?
No, it's already unmuted,
Oh, okay.
but maybe we need to.
Hello? Hello?
Yeah. Hello.
We can hear-
Oh yeah, great. So then that means this one helps us to create image image samples that we can use in another model then.
Yeah. Yeah.
So
you
then,
can- yeah, sorry.
okay. So from what we've learned so far, does it mean we use them for the decision trees, or where will we be using it for?
So yeah, this would be a convolutional neural networks based model. So if you click export, you can see some details about. So this is a Keras based model. Keras is usually used for developing neural networks. So
Mhm.
you can do, and you can, I think, see. So what you would have to do is just load, like once you've downloaded it, you get a example script on how to load it. So you can just use this to load the model into your own script, and then run it on your own computer. So yeah, this would, to answer your question, this would be a convolutional neural networks based model.
Okay, gotcha.
Yeah. So in TensorFlow, there's a command called model.summary. So model.summary, and then once you do that, you can get more information of what the model is like. Like it'll give you all the details about different layers of the model.
You smell it, Aliwa. And pray. Take off your shoes.
Yeah.
So I think JD is asking if he uploads the ingredient list of food product as an image.
Yeah, that should work.
Yeah, that should work as long as you have many food products.
Yeah, that should work. You can upload, right? Yeah. Sorry, JV, are you asking if you can provide the just basically upload images of different items and the classifier is able to classify the items based as though it was a menu, as though it's a menu?
So for that, would you need like a LLM?
Yeah, that should be fine. And I mean, you're not trying to read the menu. You're not trying
So
to
like handwriting recognition.
Yeah, that's the thing. Depends on the goal.
Depend on the context. Yeah, depend on context. We can use this system to recognize individual characters in the menu. That's fine. In fact, there is a very common image classification task where we just try to recognize different handwritings, different digits of the handwritings of different alphabets. And that's a precursor to the optical character recognition methods that we used to have. All right.
Sound and the other model.
I think some people were trying during the AI course.
Yeah.
Please.
Yeah. I'm sorry.
Which we are using. Okay. Yeah. Wait, why? If we have different postures in a trained data set, such as palm, fist, 2 fingers. No, so for this, if you want to go for different poses, you can either go for the network that is used to decode poses specifically. But for the example that you gave, that could be easily done with an image-based network as well, since you would get a close-up of the hand. So decoding palm versus fist versus different numbers of fingers would be quite simple given the sufficient amount of data set.
Generally, the way I would consider the difficulty of a image classification problem is based on how easy is it for a normal human to try to tell them apart. If it is simple enough that I can actually tell them apart by just looking at it, it's usually considered an easy problem for this type of classifiers. However, if there's some very nitty-gritty minutiae in the image that you have to specifically look out for in order to classify them, that is usually a challenging problem, and that usually requires a lot more examples and a lot more training steps in order to achieve really good performance on those models. Time. Anybody has any questions or any general questions about AI that you like to address?
Or maybe even for the bootcamp tomorrow.
Yeah, or for the bootcamp, for the hackathon.
Yeah. We're teaching machines rather than human writing code.
Yeah, pretty much. So it's basically Google preparing all the training automatically for you without humans having to type a single line of codes.
Yeah. Yeah, I guess it can work kind of like Shazam. Yeah. Yeah, this would work. But I guess the training resources for teachable machines are quite limited. So if you have really big images or a lot of images, it can get stuck or freeze as well. So maybe if you have like a small amount of data set, then it would be good.
Yeah. I don't know if there's anything else. No, yeah. There are any follow-up, or I cannot address?
The chat is moving really fast, so let's catch up with it. Yeah, so can you use it to detect bird songs or type of tree plants? I know there's a network that's specifically written bespoke for birds. It's called BirdNet. If you can look it up in your app on your Android store. There is a neural network that's written specifically for bird songs, and they are by a group in Cornell University. And yeah, quite recently I just reviewed their paper. So yeah, this type of technology has been used to detect different species of birds and from their dawn songs and from their chirps.
Okay, going back to the MLOps question. So that's more like DevOps for machine learning. And basically is a way to have, like, you can tag models, you can tag data set versions. So for example, if you have a normalized version and you have a standard version, a standardized version of your data, you can tag it with two different names. And then you can easily replicate several models on several data sets, and you can have this all this process of machine learning, which includes the pre-processing, the training, the testing, the validation, and even the deployment of the model. everything will be streamlined into one platform that can handle every process. So in a sense, it's something very, very useful if you have large amounts of data and large amount of model that you are deploying in several tasks. But also it's very complex, and from the top of my mind, I don't recall any open tool that does it, but I've seen at least 2 or 3 paid tools that are designed with this purpose.
Industrial applications in New Zealand.
Yeah.
Yeah.
Industrial for
Yeah.
what can you please give a general update for industrial progress?
Yeah.
So for like using machine learning?
Machine learning in industry, yeah. You know,
I guess so. One of the like at least in collaborative academic research, there have been works in agri-tech in New Zealand. So trying to harvest fruits through automated robotic applications. And for that, you would need machine learning based systems to identify the ripeness of the fruit, plus like how big the fruit is, and then to plan a trajectory by the robot to go and pick it up and identify the right trajectory of the robot motion so that it can reach the fruit without damaging any other things. So that is one. And then I guess in with like met services kind of stuff for flood prediction.
That's interesting. We also have a visiting what call scholar from Chalmers who's what called applying machine learning for his logistics problem.
Yeah.
So that's meant for industrial
Yeah, for
application in Volvo as I think Volvo.
Yeah, Volvo. Yeah.
Volvo. So
For scheduling
Yeah.
robotic agents.
Richard Green from Wellington.
Yep.
He has some kind of design.
Yeah.
Right.
So there's quite a lot of research that's being used, and yeah, if you have some ideas of how we can whether there's basically if there's an open problem, there may be some is probably looking into it, and there might be something there might be a machine learning solution or a related solution that's going to be applied to those problems.
Yeah, I think in even in University of Waikato, there's like a big MBIE project for agri based thing called Maratech. It's similar to Tayao, where I think they are collaboratively working with different universities and industries for the problem that I just mentioned, to harvest fruits and berries automatically.
Yeah. I saw one question about what called using the digital machines for tree plants. Yeah, that will work as well, because currently we have a research that was trying to look at different tree species from the tree crowns over using a drone images, and that's we're going to we have quite a good positive results from our early pilot usage of the machine learning systems.
Automate processes. Yes and no, it's not easy. But actually we have former Waikato student that started a company here in Hamilton. He was presenting to us sometime last year that his company basically identify repetitive tasks, and they use AI to automate this. But yeah, I don't know if that's the scope you were looking for, but yes, that could be possible.
Yeah, I think that was one of the aims of this pin, that I forgot the name of rabbit or something like
the rabbit R thing.
Yeah, so one was humane pin and the other one was rabbit R, which was designed like a box. So they have like a large action model where you just give it once a demonstration of the task, and then it can start repeating that. Yeah. Yeah, so
Exactly.
change detection.
Okay, yeah, that's that age detection questions. They try to detect regional satellite data to compare changes over time. That is really interesting because that is something that we are looking into. So yeah, it's, you have some ideas you'd like to contribute to that, we more than welcome that.
Yeah, we've also released a data set
Oh, yes.
to work on the change detection as well. So
There's a Q&A.
I guess potentially that can be used for hackathon as well.
Yep.
Yeah, so that is something that you can also use for the hackathon. If you already have some idea on this, you can explore that. And then there's a thing about habitat areas for different species. Do you want to talk about the
Sorry, can I?
manga total?
All right. So sorry. Track extinction of species and innovation to classifiers, habitat changes in small sample areas, and GPS codes of locations. Yeah, that's also another project that we are looking in that we are working on. So this involves the Manga territory habitat, what call Sanctuary Mountain, and basically they had a lot of trail cam cameras, and they needed to basically track in the how well the kiwi species, the kiwi birds are recovering, and also if there are many possible potential invasive species that are well, especially rats and possums that might have broken through the fence. And yeah, we've been working well in it, and then so far we have been getting quite positive results from our system.
What about this? Do you have any comment on
Right.
the cash flow?
All right, there's been quite a lot of repetitive process involved in managing cash flows, logging into various bank account. Could AI go that far? Sorry, I'm not sure if I followed that question.
I guess it's they are asking about how the money is moving between bank accounts. Can AI be used to track that?
So for like fraud detection and stuff like that. So yeah, I think Bakal, there is actually one area of research because as you notice, I remember Albert mentioned about anomaly detection. So basically some people do use AI systems to detect what called anomalous or surprising transactions that are beside norms. So most of these what you call money laundering process do trigger those anomalous activities, and AI systems have been used to try to detect what call strange trash flows. Yeah.
MLOps applications.
Okay.
I have no idea about MLOps.
Yeah, I'm not.
At some point, I think Justin told me a good one. I'm trying to find it. I'll send in the chat when I find.
Sorry, we had a good response to the ML ops. We're just trying to look up the response. Sorry.
We'll respond it in the chat.
Yep. All right. Any other chats? I lost track of all the chats.
I think we've been covering all the questions so far.
Okay. Sorry. Yep. Anybody have any thoughts? Anything?
I was thinking more about eliminating.
Okay. So basically to automate your regular transactions and stuff. Yeah, I guess. Although personally, I would say that it might be dangerous. It might be a dangerous thing to trust money onto
AI.
yeah. I do know that for myself, I do have my own financial software which I I have my own scripts and my own code to try to automate and classify them accordingly. But the final go no go decision is always manual, even though I have full control and I theoretically know what those those scripts are supposed to do, but I'm still quite hesitant to basically trust my finances to autonomous system.
Yeah.
Like as Albert bring up, when it comes to ChatGPT, especially like ChatGPT, it's always useful to, it's quite obvious. It's important for the humans to make the final decision and not fully rely on autonomous system to make very important decisions.
Yeah. However, like there are some trading bots that you can use, but then still, I guess right now they are more algorithm based rather than AI based, or at least I guess, yeah, they can, depending on how you look at them, they can be considered as autonomous models or agents versus algorithms. So, yeah. Back to LLM, did Professor mention what's RAG?
Retrieval augmented generation. So it's basically a way for a method for LLMs to retrieve what called data of this. Basically, you upload a document and the LLM try to summarize and try to and you're able to retrieve information from that document that you uploaded. No, Albert did not go into detail about RAGs, but it is a capability that are available in LLMs. You have done something to that effect with the cash health thingy.
Yeah.
Yeah.
So yeah, you would have to provide some, like if you are going to do some sort of retrieval, then yeah, you need to provide some knowledge on that to your GPT. But yeah, if you're using something like ChatGPT, you can create your own models, and yeah, you basically don't have to do any coding to create one specific to your own requirements. We've been playing around with that a bit as well for estimating health of different estuaries in New Zealand. So you just give it a set of instructions of how you want it to behave, and you provide it with some data that you want it to focus on. And based on that, it can adapt the general ChatGPT resources to solve your particular problem. Human in the loop is very wise and recommended by a range of AI systems.
One note about the human in loop system. The EU AI Act does classify AI systems to fighting like 4 different categories. So in most of the risk category that they specify, a human is always in a loop, and ultimately any decision that's being made, a human must always be there. Must always be a person that's accountable for the decision. So
human as a supervisor then.
Yeah, pretty much. So basically you need the AI tool can be used to assist in making the decision, but the buck stops right there. The human needs to be the one that says yes or no to the decision that's being made. Okay. Yes, you want reverse centaurs and not reverse centaurs. Sorry, I don't get the reference.
Yeah.
All right. Okay.
Any other question?
Yeah. So RAG is good for reducing hallucination, but if the goal is to have the model draw out context, what they say, isn't fine-tuning or simply embedded it in some system prompt better? Yeah. RAG. Okay, just not to spend too much time into the minutiae of the things, but there is still an open question on whether RAG system hallucinate. We probably need to take the discussion offline, but I haven't done enough research to actually come up with a conclusion. There is a YouTube channel by the name of Yannick Kirchner who did a discussion on that topic, and I do know that Yannick Kirchner has a background in language models, in large language models, so it'll be interesting to hear his to watch the video and then hear his input and basically come on your let's say like have a feel about whether what he say makes sense.
What's the link for
And
the
the YouTube channel? I can look it up. So you like
Guillermo already did.
okay. So I can pick up the
So-
particular video.
Okay. So the link we already put is the link to the channel. We'll try to find the exact video Nick was talking about and add it in the chat as well.
So that's fine. So just a note, he was quite negative about the paper, so he wasn't very impressed with the paper.
work.
Yeah. So that's like video. All right. Anybody have any thoughts or any questions?
How is the meeting gonna be?
See, so with the Tech Connect would have the videos. We will send the link to the recording of the videos. I will call once the video has been processed. So we'll be probably sent out through email and along with the slides, and then you can pretty much follow the contents of the slides and the videos.
Yeah.
All right. Cool. Right.
Yeah, I guess we can end the session for
Yep.
today, and tomorrow we meet at
We'll
9.
start at 9.
Yeah.
So so we'll start tomorrow the session will start at 9 o'clock. So whoever signed up and enrolled or would like to learn more about the programming bits of how to implement a AI system, we'll go about that. So the work will cover tomorrow's session will cover on Python, on using pandas to process our call data, time series data in particular. We also cover on scikit-learn, and then we'll end with a quick demo on a quick tutorial on how to use our call PyTorch, Keras PyTorch for your classification. Okay, Guilherme did have all right. Otherwise, thank you very much for your time, and we'll send the links to the videos once it's fully processed.
Yeah.
Okay.
Awesome.
So thank you.
Thank you. Bye-bye. Take care.
All right.